And welcome back. I hope everyone is having a good day thus far. If you're watching these videos in series, in the previous video, we finished up getting the hardware elements of our supercharger installed. And that included finishing up connecting the radiator to the block, which meant upper and lower radiator hoses. Also completing the V6 electric fan modification, in which we're not going to go back with the clutch fan, but instead going with a slightly bigger fan that replaces the condenser fan and the shroud with an all one-piece unit. Again, this is the type of cooling fan that V6 1500 would technically have. Not technically, but would have, depending on the model. And we also got our inlet air filter taken care of, as well as it's now plugged into the PCV hose. There used to be a hard pipe on these 1500s that went from that PCV port on the other side of the oil fill over to the hard air box that is now replaced and being plumbed into this air system as well, so mimicking that piece. Also, our overflow coolant tank has been installed as well. And then we buttoned up a couple of items, such as putting a little piece of rubber here to prevent any wear that might happen should this tank decide it wants to reach over and say hello to our pipe, as well as, if you remember the previous in the the transmission line, one of them with the metal collar. Basically, this section of the transmission line was crimped, was kind of hitting the bottom of the supercharger bracket. So we also secured that with a bit of a insulating rubber as well. And at the end of that video, like I said, it took care of all the hardware components. So at this point, we're up to fluids. And I think the first fluid that we're going to tackle in this video is going to be the radiator coolant. Now, if you remember, we flushed the heater core on this, and that was the only piece left of the cooling system that still had any residual coolant from whatever the previous user had in here. And what they had in here was the orange coolant, so it looked like it was potentially the Mopar 5-year coolant, but that's just a speculation on color. Now, even though we flushed it with a pretty good amount of distilled water, and it should be mostly distilled water in that heater core at this point, I don't want to take any chances with it. And by that I mean I was originally potentially looking at replacing the 5-year coolant with Mopar's 10-year coolant. And the differences being one of those coolants, I believe it's the 5-year, don't quote me, but I believe it's the 5-year, that's the OAT coolant, and the 10-year is the HOAT coolant, yeah. Organic acid technology and hybrid organic acid technology. You don't want the purple and the orange stuff from Mopar to mix, per se. Very bad things will happen. It'll end up being kind of a gunky sludge that will build up everywhere. So with that being said, and just kind of erring on the side of caution, since what came out of this block and the radiator and everything was the older orange looking stuff, and even though we have the heater core flushed and diluted, we're just going to go back in with the 5-year coolant just to be on the safe side. I'd prefer 10, but 5 will work just fine. It'll also safeguard us in the future in the event that we ever take this truck in for service work and somebody happens to look up the VIN and or the make, model, and year and say, oh, it's low in coolant, let me just top it off while I'm here. And they look up the coolant type based on make, model, and year and dump in what the book says it should have, but yet they don't know that maybe we've changed out with something else. So with that said, if you've watched my channel before, you've seen me do this a couple of times with a slightly different unit. But this is, we got a newer unit based on watching a video from Wes Work a little while back. And I like the style of his tool to do this fill versus the other one that I have. The other one I have works, don't get me wrong, but it started to develop some leaks. So we went ahead and picked this one up, and I'll put a link in the description of where I got this on Amazon. But you can see it's an OEMTOOLS air coolant refiller. It's at least in this one is part number 24444. And what it does, just like my other vacuum filler, it uses a Venturi effect. So by running through this piece here, high pressure air across here, it causes a low pressure differential to be formed here. And thus, or depending on where you got your valves set, and you open up the passageway from here down through here, where you would normally have this set in your radiator, it can then pull the air out of the cooling system and discharge it. And according to OEM's manual, once we get down to about 24 inch grams of mercury, then we're going to stop the process, wait 20 seconds, verify that it will hold, and that we don't have any leaks, and then we can open up the necessary valves to begin coolant fill. So there, it'll start displacing and pulling coolant into the system via the vacuum that we just created in the cooling system. So it's a bit more of a thorough method of making sure that you've got all the trapped air out of the system. And it kind of helps you with, you know, the refill and the whole burping and purging process. Now, again, like I said earlier, we're going with the Mopar 5-year coolant, and there's your part number there. Now, please note, this is the part number for the concentrate, not the premix. We are going to premix this at a 50-50 per their suggestion. That's usually how I do all my Mopar vehicles. And we're going to be using just some standard distilled water to make this mixture with. I like going with the concentrate because if I'm doing a large job like this, you can get the concentrate for generally the same amount of money as the premix. But the bonus is, since you get a gallon of this and you mix it with a gallon of water, if you're doing 50-50, you end up with 2 gallons of coolant for the price of that you would pay for 1 gallon of premix. Now, if you're just topping the system off, or and you may only need a gallon, yeah, then by all means, you know, buying a 50-50 premix makes sense. So what I'm going to do is get this contraption set up on the radiator, and what they give us here is a selection of plugs. I kind of looked at these earlier, and once I now retrieve said bag of plugs, so we're going to get a rubber plug set up in here to take place of our radiator cap. What's going to happen is this first apparatus here is going to set down inside the center of that plug, and as we tighten this down, this is going to expand and help create our seal. Then once we have this in place and we have it sealed, we can then start the next process of this, is kind of getting everything set up. Now, I looked in the manual several times and I can't find a rating for shop air about minimum or maximum PSI that you can feed into this particular tool. I tried to Google it. I tried to look at some other individuals' videos, and everybody seems to be using it, but no one exactly states what they're using for output. I'm going to try about 100 PSI coming out of this compressor here. It's just I think that's a 35 gallon or 40. I think that's probably about a 30, 35 or 45 gallon tank. I forget off the top of my head. Now, this one can do it. I've used this one with my other vacuum fill system. However, it does take a couple of rounds. That tank there, it just doesn't have the capacity needed to push enough CFM through one of these in a prolonged period to reach full vacuum. So generally what I have to do is let the air compressor fill up, kick off, let it recharge itself, open up the vacuum port on the fill to the point the compressor starts to run again, cut the vacuum, let the compressor fill up, and then usually maybe about 2, maybe about 3 cycles of that we'll have full vacuum, and then we can continue. So when I get you set up here in the tripod and we film this, once I start the process and the compressor kicks in, I'll stop you at that point, because all you're going to hear is a bunch of hissing. I mean, I'll show you the valves we're going to open before we do it, but all you'll be missing is a bunch of hissing of air out of this tool, and a bunch of cycling of that compressor, which is going to make it loud enough in this small garage you're not going to be able to hear what I'm saying. So let me get you set up on the tripod. We'll get this tool set up here, and I'll bring you back. One moment. And welcome back. So I got you on a flexible tripod hooked up to the top of the radiator support. Got you pretty close to the fill neck there. And inside the kit, they give you various of these little rubber spacers. It's just a matter of finding one that will fit snugly, and it looks like that one will do a pretty good job. So that's a 42 millimeter in this case. Like I said, they do give you several other ones. Looks like you got a 31 millimeter, a 40, a 35, and a 45, as well as this cone device here. In case neither one of those fit, then you could just kind of generically go in there like that with a cone, or if you've got a recovery coolant bottle. See, in this case, we can go in straight through the radiator neck. Sometimes you may have a setup where you fill the cooling system through the coolant bottle and you don't have a cap on your radiator. So we got our little stopper, or the first bit of our stopper. That'll work for us, and like I said, it fits in there pretty snug. Yeah, that's a pretty snug fit. Yeah, we can still get it out. I was debating on putting a little bit of lube on that, but it looks like that'll work just fine. So what's going to happen is this, which has a rubber insert on it, is going to go in the center of here, and then we're going to expand that collar out. Yeah, so that's getting a little bit tight because now that we've got it inside the radiator. So what I'm going to do is just hit this with a little bit of silicone on this rubber piece here, just to kind of help that along. Again, not a terrible amount, and it is silicone. If you've been watching my other videos, silicone parts, rubber parts love silicone. We're not going to degrade anything. We're not going to put so much on this as to get any kind of silicone contaminant within the cooling system itself. Okay, let's see what we got here. Yeah, let me grab one of the other spacers. This one's tight, but it's collapsing that inner circle way too much to get this tool in there. So that was a 42. Let's try the next size up. It's 40, it's 31. I think the next size up is going to be a little too big for what we need. Yep. So we're going to have to make the 42 work. I would expect this to be a tight fit. Alright, so we're going to do it this way. So I've got their spacer on the tool first. Okay, there we go. Just took a little bit of persuasion, but we're there. Now we could take this lower lock ring. I think that would be enough. Yeah, that seems like that's got that expanded out quite nicely. We'll find out if we got any leaks around there, and then we may have to just revisit So this is our fill tube here coming off to the side. What I want to do is I'm going to turn this apparatus because our fill bucket is off to the side here, just to show you. Now what I'm going to do, I'm not going to mix all 4 gallons and have it sitting in this bucket. We'll have to straighten out our tube here because that's getting annoying. I'm going to mix basically 2 gallons of coolant at a time. When we go to fill, we're just going to keep a good eyeball on our water level, and as we start to get close to the end of that, where we may start pulling in some air, we'll cut our flow by cutting our valve here, and mix up the next 2 gallons of coolant, and then we'll continue the process until we are full. Really wish, I don't know, it's just the way that we got it. Unfortunately, we've got to kind of look at the gauge a little bit upside down and sideways, but tell you what, let's continue to turn that. Let's just look at it this way, and it doesn't look like I can rotate that gauge any, so either way, no harm, no foul. We'll just look at it upside down. It's not going to hurt the operation of it. So what we have here is that this is in this position, the valve is off. So it's not going to pull any liquid or air from our liquid fill line. This is the valve that connects up to their Venturi device. With this now being off, there's no passageway between this fitting or between this space and your cooling system. And then finally, we're dealing with this piece here, which is going to plug onto our other piece that we were just referring to. And my understanding is this port over here, which actually we want it to go this way, just kind of off to the side. And be careful of that one. We may find a container just to put this in, but what this line is supposed to do is to be able to help discharge any excess coolant that might be in the system, because what's going to happen is we're going to draw a vacuum, we're going to draw it up, and if there was any excess coolant left in the system, it will potentially pull that liquid up and then discharge it through this line along with any air. Now our system is pretty dry other than the little bit of liquid that's in the heater core, but I don't think it's going to pull that liquid out of the heater core and make it all the way up here. So I think what we're going to have here is mostly air, so we should be just fine there. Now, this is our on valve, so in that position, we're off. So what's going to happen is we'll hook up supply air here. We'll cut this valve on, which means it'll still do, you'll get the Venturi effect. You're going to hear this start to hiss, but it won't start to attempt to draw a vacuum on the system until we hit this valve here. Once we turn this one on, opens up that passageway, it'll start pulling a vacuum. Now, as we said earlier, once the compressor kind of starts to not be able to keep up with the demand of airflow, what I'm going to do is cut this valve, and instead of it being like that, we'll cut that valve as well. That'll turn this off, that'll isolate it, we'll let the compressor catch up, and then we'll come back and turn this valve back on first and then this valve. Finally, once we've reached our 24 inch grams of mercury that they're looking for in the gauge, telling us that we got sufficient vacuum on the system, then we'll cut this valve, disconnect our shop air, and then we'll wait 20 seconds. Now, there is a procedure that I've seen some individuals do for bleeding this line. I'm going to look over that procedure really quick. Now, if I remember correctly, what it entails is leaving this valve off, you turn this valve on to, again, create your vacuum, and then you turn this valve on ever so slightly until it pulls coolant out of the bucket, comes up into here, and basically starts kind of spitting out of your line here. And that just gets rid of, you know, potentially the air in this hose ending up in your cooling system that you just evacuated. If I remember correctly, that's the method for it. So what we want right now is that valve off, this valve off, and this valve off. And what I'm going to do is get the compressor powered up, let it get itself charged up here for the first run, and then I'll bring you back. So one moment. And welcome back. So I got you on the other side of the gauge here, so hopefully you can see me what levers I'm flipping a little bit more clearly. So we got our air compressor filled up, we got a shop air supplied, and we're currently set to about 100 psi. So I'm going to open up this valve first, which will create our Venturi effect, but however, we still have the valve going to our cooling system isolated. So as soon as I turn this on, and headphone users beware, you're going to hear basically a loud hissing air noise. Once this is established, then we'll cut this on. But as I said previously, once I hear the air compressor start to run, then I'm going to cut these two valves off until it can recover, and then we're going to kind of cycle that until we get to this, negative 24 inches of mercury that they're looking for. And once we get to that point, I'll bring you back. I'll let you see the gauge, and we'll see about getting the 2 gallons of coolant prepped into our bucket. So let's start this. Okay. I see an issue. I see an issue. This rubber stopper isn't going far enough down to block the tube that goes to our overflow tank. So it's basically venting out the overflow tank. So what we got to do is pinch this line off. And let me get something I can pinch that line off with, or seal that line off with, and then I will bring you back. Yeah, see the fill tube for that's way down here. I thought that stopper would be tall enough to have enough length to cut that one off, but I guess not. So one moment, I'll bring you right back. And welcome back. So we're going to see if this is going to work. Again, just a spare piece of rubber tubing around some needle nose vice grips. Now that we've got this line, I think, pretty well pinched off, and just using the rubber tubing to help protect the line so the jaws don't bother it. Let's get you set back up where I had you. Okay, there we go. So once again, let's give this a shot. Okay, vacuum's coming up. We're about almost negative 20. We've reached negative 20. I'll get you a shot of the hoses that are collapsing. Okay, we are at our target of negative 24. So we're just going to let it hold there. And interesting enough, this tool seems to be a bit more efficient. Yeah, I think we've met the fact that we're not seeing a leak, which is awesome. But this tool is more efficient. I was able to do that with one compressor run. The other tool I have isn't, like I said, it takes 2 or 3 runs of the compressor to do that. And that did that on one tank, and it's not close to kicking on yet. So this one is much, much more efficient. I like it. So what I'm doing behind you is just mixing up a gallon of the concentrate, which in this form, and I'll show it to you, looks more translucent. I don't know, kind of looks like a neon purple bluish color. Let me see if I can get you to see this. There we go. Check out that. It's actually kind of cool. And while I got you, you can see our radiator hoses are nice and collapsed under the vacuum. Let me get you back on your perch here. So that's 1 gallon of concentrate. I'm going to mix in a gallon of distilled water. Oh, you're falling there. So let me do this. Let me get this mixed up and I'll bring you back. One moment. And welcome back. So we're still holding vacuum in our system after all this time. So we definitely exceeded the 20 seconds. We got a gallon of concentrate with a gallon of distilled water mixed, and we got our hose in. Now I'm going to attempt to purge this line. And I'm going to have this line just go into this bucket or into this empty gallon of water, or the bucket we got from emptying a gallon of water, at least until we see fluid come into this line and go out of that line. And if I remember correctly, what we have to do is I'm going to leave the system, the core, blocked off, restart our Venturi, and then open up our liquid line here slowly. Okay, well, messed up on that one. Got a little bit of air in the system. I didn't purge that correctly. But either way, it may have. Actually, it may have. It may have drew it out through the Venturi. We'll have to see. But sorry for the compressor noise. You can see the level in our bucket is going down pretty rapidly. I need to keep an eyeball on it. You can see our vacuum is dropping. So let me pause you so I can keep an eye on it, and I'll bring you back. One moment. And welcome back. So we got our 2nd gallon mixed up. I'm going to reopen our valve. I'm going to let it drink. You can probably hear the hissing. You can see our vacuums continuing to drop. Awesome. It actually pulls it down quite fast. That's a pretty good diameter size piece of pipe. Like I said, so far I'm really loving the OEMTOOLS version of this. Like I said, the other one I have, it gets the job done, but again, this one was able to do it in 1 run of the compressor instead of 3. And because of this nice size tubing, it has a much faster fill rate. I don't have that valve open right away. I'm kind of just letting it take it slow. But you can see that vacuum gauge is steadily continuing to drop. Eventually, you should see our hoses start to inflate again. Yep, I can definitely hear it filling the radiator. Still dropping. Fluid level in the bucket looks good. Four gallons should be more than enough to fill this. Oh, we're coming up on -5. We're almost out of vacuum at this point. Just keeping a steady eye on our bucket. We're almost done. Upper radiator hose is starting to inflate a little bit. Almost at 0 on our gauge, just a little ways to go. see our upper radiator hose. Starting to take more shape. Still got plenty of coolant in the bucket. And we got a little bit of vacuum left. So what I'm going to do, and I've had this situation before, I'm going to cut the valve right now. I'm going to pick the bucket up and make sure that that weight stays at there. Basically, just kind of tip it like this and then pick the bucket up and give the bucket a little bit higher elevation. And then normally you can get it to pull the rest of that in. As you can see, it's just almost there. So let me do that and I'll bring you back. One moment. And welcome back. Well, as you can see, we're down to 0. And all combined, we probably got about a gallon or so left in our bucket. So we used about 3 gallons of coolant to fill the system. Now, does that mean that we're done? No. What we'll do is, on the first startup, we'll get a spill-proof funnel in here, and we'll just have it topped off full of fluid. And that way, if there is any air, which there will be a little bit of air in the system, you saw me, I don't think I purged this line correctly when I did that. But any of that little bit of air, like I said, we'll get out of the system during the first startup when we have our spill-proof funnel in here. But the nice thing is, this took care of the majority of the air in the system. And like I said, out of 4 gallons of coolant, it looks like we got about 3, maybe a little bit more than 3 gallons of coolant in there. That's a nice other thing about keeping a hold of these jugs, especially the concentrate jugs when you mix them. What we can do is, what I like to do is I'll use these jugs and basically just refill them with any unused coolant and just mark on here that it's now a 50-50 mix. So I'm going to get the contents of whatever's left over in that bucket dumped into here, and when I bring you back, I'll tell you whether it was a gallon or a gallon and a half or so. And also, one note on the bucket I forgot to mention, this bucket is only used for coolant. It's kept in the garage, it's kept clean. I keep a lid on it along with the mixing utensil, just available in any nearby kitchen. Just don't tell your significant other. And all of that gets cleaned off, stored in the bucket, and we keep a lid on it. And this bucket is only used for mixing up batches of coolant, again, just to kind of cut down on contamination. So what I'm going to do is work on getting this contraption detached, and then we can start with the shop air. We no longer need it. And then we can get the Venturi off of here next. Nice, just quick disconnect fitting for everything, which is awesome. And then we can work on getting our valve out of here. Now we should just be able to crack this valve and then pick this up to get this coolant to drain out of this line. So let me concentrate on getting the valve out of here, and I'll bring you back. One moment. And welcome back. Well, you can see we've got our radiator topped off. And when you're removing that vacuum device, that feed line, because you still have it closed off from the radiator being full, once you break the seal here and remove it, once that bottom piece of that device gets air, if you open up the feed line, you can let air and gravity just kind of bleed that line, or what's left of that coolant and that supply line, back in your bucket. So after getting everything disconnected and topping off our radiator, we got the residual just poured back into the bucket, back into one of the jugs here, and it looks like, based on fluid level, once I can get some light in here to see what I'm doing, yeah, it's probably about maybe a little bit more than half a gallon. So I would say roughly about 3.5 gallons of coolant to fill the system, maybe 3.2, 3.3, maybe somewhere around there. So let's just say about 3.5 gallons of coolant to fill the system as it stands. And like I said, during the first start, we'll have a spill-proof funnel on here with another reservoir of coolant on it, and we'll thoroughly wait and run the internal cab heat for the cab, and just wait for the thermostat to open, just to verify that we do in fact have all the air out of the system at that point. But Like I said, I love the performance of this one. Like I said, my other one works just fine, but I'll have a link in the description of Amazon where I purchased this one. Like I said, it seemed to work good. It worked fast. It looks like it got to probably, I'd say, what, maybe 98, 99% of the air out of the system, with the exception of that, maybe that little bit of air that I think got in from the supply line. Like I said, I had the Venturi open, and then I opened that one, so that air should have gone out, but I don't think that it did. Either way, it was just a small amount of air combined in that hose. Will thoroughly burp the system, like I said, on that first startup, so I'm not too concerned with it. But again, majority of it's done. Enough rambling on about that. Let's move on to the next piece. Let's go ahead and get the rest of the oil dumped in our crankcase that we're going to use for our break-ins. So let me go grab those supplies. I'll be right back. And welcome back. So we finished it off for now with a nice shiny new radiator cap put out by Gates, and there's our part number. So as I promised, let's move on to getting the rest of the break-in oil into our crankcase. Okay, I'm gonna have to get up there and study that, but yeah, you get the idea. So you probably still saw this on a previous clip, but in case you're watching these out of order, this is what we're going to be using for our break-in oil, put up by Lucas. Break-in oil, high zinc content, and 5W20, which is the weight specified for this particular Hemi 5.7. And the reason why we're going with this is when we picked the short block up from the machine shop, I asked them what their recommendation was for break-in oil, and they gave me their recipe, which they didn't say that I couldn't repeat. I won't say where I got it from, but they use standard. So in this case, they would use standard 5W20. They would add a zinc additive to the oil, and then they also follow it up with a Lucas oil treatment, and they use that for their break-in, and says it's worked quite well for them. So when I was Google searching it, I then came across this, which I got from Summit Automotive, and said, well, you know, this kind of looks kind of perfect. It kind of matches what they said to a T, except this is just happens to be put out by Lucas. Break-in oil with the zinc content and the weight that the motor is looking for. And also in the previous clip, we put about a half a quart of this. We got about just shy, maybe about half a quart of oil we were able to get to soak into the filter, which has already been installed on this vehicle. So again, not looking to spark a debate in the comments about whether you should or shouldn't do it. The reason why we did it in this case, beyond whether you should or shouldn't do it, is that since this engine is new, and really the only lubrication on anything right now is just the assembly lube, or oil that we applied ourselves when doing things like putting the timing components in. We want the oil system to prime as fast as possible. So by pre-filling that oil filter, with this, it should take hopefully a few seconds off of what it would normally take to prime itself, and hopefully, the goal is to get it to prime itself just that much quicker. So I'm going to go ahead and put the rest of this in, because Hemi 5.7, when you do a filter, is a 7-quart oil change. And what we have here is a combined total of 7 quarts. We got about 6.5 left over, again with the half of it sitting inside the filter. So I'm going to put all this in, and yes, when we check the dipstick, it's probably going to show a little bit overfilled, but that's fine. Once we start the motor and we get oil inside the oil pump and inside the pickup tube, and it starts to spread it throughout the engine through the various bearings and journals and channels, and that level should drop to what it would normally look like during a standard oil change. So we're going to go ahead and get this added in, and I'll bring you back. One moment. And welcome back. So we just got done adding oil in, I should say. So I just wanted to show you here. Now when we check it on the dipstick, now remember we got about a half a quart of this oil in the filter already. The other 6.5 we just added straight to the crankcase. Let me find the marking here for you. Hopefully you can see that. The full mark is right there. So your safe range goes from here, which is add, to here, and we're just a touch over the full mark. So once we start up and it finishes priming the oil filter and the other engine components, we'll probably come down to about half, maybe a little bit more than half within the safe range. I mean, we'll keep an eyeball and check it. If we need to add a little bit more, then we will. But right now, where it's sitting, looks perfect. Again, knowing that most of the oil filter is already full, so that level shouldn't drop considerably, knowing it doesn't have to fill the oil filter up as much. Okay, so we've gotten coolant, we've gotten our oil into the crankcase. I think the next thing we can do is get out some ATF4 fluid, add a little bit more transmission fluid to the transmission, again to account for having a new transmission cooler line set, the new transmission cooler itself, which again is built into the condenser, as well as adding that new Circle D torque converter. So we just want a little extra fluid in there to kind of compensate for what it's going to use to fill those components back up. And I'm thinking probably about a half a quart for the new line set and the cooler. And then, of course, the converter, which we did pre-fill with a half a quart of fluid, is going to eat a little bit more than that. But I think what we'll do is we'll just start with an extra half a quart of transmission fluid. I did look over Circle D's installation instructions, and I'll have another gander at them while we're doing this, but it just says to add extra fluid. Obviously, they can't give you an exact amount because each vehicle is different, but I figured we'd start with an extra half a quart. As well as we have a very thirsty power steering pump reservoir in there as well, and on this particular make and model of Dodge, it uses the same fluid as the transmission, so we need some ATF4 for that as well. So let me go grab some bottles and I'll be right back. One moment. And welcome back. So just got a little of the Valvoline ATF4 that we've been using on this transmission thus far. It's from the same case we did a few months ago into the first series in which we were getting the truck back on the road, and we did a fluid and filter change in the unit. So I'm just going to use some more. There's also the same exact bottles and from the same case that we use to pre-fill the torque converter. Now, looking at the Circle D instructions, they say to add a few extra quarts, plural. So I think what we may do is, like I said, I think I'll do, we'll check the level. I'll add a half a quart. We'll check the level. We'll see how much higher we are on the stick and go from there. But we may have to add, you know, a quart or more after we start it, and once the transmission's had time to prime the lines and the new torque converter, and basically we just want to keep an eyeball on it and make sure that it stays full. Let's see if I can change your view here. There we go. Okay, so again, just using ATF4 in the power steering pump. Man, that's what the manual calls for. Same fluid that we use inside the transmission. Now, they have an interesting fill procedure, or at least All Data has an interesting fill procedure from the OEM on this, and I don't have the device to do it with. Is they actually have you attach like a hand vacuum pump to this after you fill it and apply hand vacuum to it until you get all the air out of the system. It's kind of their way of purging the air out rather than filling the reservoir, starting the vehicle, and letting the pump purge the air out on its own. Typically, what I've seen a lot of people do is that you just fill them, start it, move the steering wheel from left to right in a couple of successions, and yeah, the pump will be a bit noisy for a little bit until it eventually works all that air out on its system. But what Mopar wants you to do is actually draw a vacuum on that, but I don't have that adapter or that hand pump to do that with, so we're going to do it this way. Now I can actually hear it filling up the power steering lines. You can kind of hear it gurgling through, but I need to get a shop light in there because I need to keep an eyeball on the mid and max lines on the side here. So let me pause you. I'm going to go ahead and continue to fill this, and I'll bring you back. One moment. And welcome back. So I figured I'd show you this. What I'm doing is just shining the shop light on the side, which is doing a really nice job of illuminating that bottle, because it's, I don't want to say transparent, but it's kind of see-through. It helps us see that level, and I can tell you right now, this is probably going to take a quart or more to fill this up. So I want to say we're working on the first quart here, and we're not quite up to our line yet. We're getting close. We're about halfway to our line, and we're probably about a quart in. So I'd say maybe another quarter to half a quart, and we'll be at the min line. But what I'm going to do, I'm going to take it to the max line. That way, when we start it, as it starts to fill the steering rack and such, it's got a little extra to draw from, because I don't want the pump sucking in a lot of air for a prolonged period of time. I want there to be plenty of fluid in there, just so that we don't run an issue of burning the pump up. Okay, so I gotta go get another partial bottle. So that was 2 partial bottles. That's about a quart. We're not quite up to the minimum line yet. Anyway, again, I'll finish this and I'll bring you back. One moment. And welcome back. So it took about 346 milliliters out of this bottle, not quite a half a quart. So I would say in all combined, maybe about 1.34 quarts. And I'm sure it'll take more than that once it's said and done, but hopefully I can get you down in here to kind of see this. This may be a little bit hard. Well, actually, I'm going to describe it to you because I'm not going to be able to get camera close enough and it won't focus. But the min line is here, kind of where you see my finger, and about maybe another quarter inch above that's the max line. So we're full right up to the top of the max line. Again, I don't want to go fuller than that and kind of overfill it, cause it to sploosh anywhere, but give it some working room to play with. So we'll go with that. And like I said, we'll have to keep a close eyeball on it on first start. Let's see if we can get our cap to actually close where the lettering is straight. And no, it's not going to cooperate. And like I said, we'll keep an eyeball on it at the first start, and we'll kind of add from there. So we'll use what's left of this quart now and get that dumped into the transmission. But first, let me move the camera over. We'll do a quick check on the dipstick and see how much fluid is currently shown in the pan, and we'll go from there. So one moment. And welcome back. So I just got one leg of the tripod pinned between the high pressure line and the fender. So you're kind of wobbling a little bit if I hit the camera, so I'll try not to hit it. Now granted, we're checking this transmission cold. We're checking with the engine not running, but the truck is pretty level. And just to show you here, the hot marks over here, and we're slightly above hot. Now again, we're checking this not running, which is not going to really give us an accurate reading, but it will give us an accurate reading of how much oil is in the pan, which it looks like the pan is pretty full. Now granted, that level will drop as it fills those new lines and the cooler and the torque converter. So we're going to add a little, probably like I said, about a half a quart or so into here. Now when we first start, what I'm thinking we'll do is, of course, when you first start the motor, it's going to hopefully run okay, and it'll kind of go at high idle, and eventually as things come down, it'll come down to a normal idle. So when it's running at normal idle, then we'll have to come out here and check the transmission fluid real quick and just see if we have to add any. Now we could, in theory, what I think I might do is that run it for that brief few seconds when it's at high idle. When it comes down to a normal idle, shut it off real quick, let things settle, and then come here and check it. Now granted, it's not checking it while it's cold, but it will give us an idea of how much fluid has dropped in the pan, because we just did this measurement, so we know how much is there now. And that'll give us an idea of kind of how much we need to add. We can add that much more fluid and we'll start again. What I don't want to happen is it needs so much extra fluid that the pump gets starved for fluid, and we end up damaging something as a result. So let's see how much we got in here. We got, okay. Yes, I have a very small, very narrow funnel, but it does a really good job of fitting inside this dipstick tube. We're almost there. So this is going to be a hair over, a little over an extra half a quart of fluid. I think that's a safe starting point, especially once it gets everything again purged and filled. And if anything, I'd rather be in a position where I have to add a little bit of fluid and not have to take a bunch of excess fluid out of the system. Considering we haven't put the new drain pan on here yet, so it's a little bit more cumbersome to drain excess transmission fluid out when you don't have a drain plug to do so. Okay, let's see. So, like I said, that was a little over half a quart. That's what we had left over from filling the power steering reservoir. And we still have 3 more quarts of that same fluid from the same batch ready to go in the event that we do have to add more to this system. So, and now obviously probably goes without saying, but not that it's directly underneath of it, but since our dipstick port for our transmission and our air cleaner for our supercharger are within close proximity, just I guess have some towels on hand and try to minimize any drips that may end up on that air filter element. Okay, let's see how much further up the stick that put us. Okay, yeah, we gained a little bit. We're now to about here. We were about here previously, so now we're about here. So we're almost up. Let me just get the stick wiped off here. We're almost up to this first bend in the dipstick. So I think we got plenty of fluid in the pan at this point, at least for the initial start. Per Circle D's instructions, they just wanted to make sure that the transition pan is full, and it is. And like I said, it's just we got a lot of things we're going to have to keep an eyeball and an ear out for when this starts the first time. I'm not trying to make it sound like doom and gloom. Don't get me wrong. It's just part of the process. Okay, put our funnel. And with that being said, there is one fluid that is still missing, and we won't add that until right before we're ready to prime the fuel rail and start things up, and that's going to be gasoline. It had a little bit of 93 octane in it when we parked it, not much, but a little bit. I want to at least get a couple extra gallons of nice fresh pump 93. Add it to the tank, because what's in there has obviously been sitting there since it's been parked in the garage, and that's been quite a few months at this point. So we get a couple of gallons in there at least. Let it mix in, get things nice and fresh right before we're ready to prime the fuel system. So with that being said, we're going to probably call it a video at this one, and I understand it's going to be a little bit short. I do apologize, but I think we'll cut this one off and just consider this our fluid fill and top off. But when we come back, then we'll see about getting a battery in it. We'll do a power on test. We'll do the code scan at that point to make sure it's not telling us that it sees a sensor missing, something along that nature. And then we'll look into programming the banks, iDash, the pedal monster, and then finally reading the current tune from the vehicle so we can get it off to the tuner for their adjustments. Now, for safety's sake, before we apply any power to this truck, remember we have the external fuel relay bypass off of our TIPM. So we're going to pull that fuse right there to kill power to the fuel relay. We're also going to take it a step further just for precautionary sake, and I'm going to take the control wire and just clip it loose from the starter real quick. So in the event somebody accidentally turns the key too far to the start position, it won't actually try to turn the starter over. It's safer now that we've got oil in the crankcase, so in the event things start to spin and it starts to draw something up, it can now draw oil up into it. But I don't really want anything rotating to start to rotate yet until the new tune's in, because otherwise it'll probably just freak the PCM out, you know, seeing things in places where it shouldn't be, if that makes sense. So with that being said, I will call it a video on this one. And if you have subscribed already, I do thank you immensely. If you have not, please consider doing so. We'll call this one a wrap, and when we bring you back, we'll handle the electrical and the programming side of things. With that being said, I'll let you go and bring you back for the next one. Thank you much. Bye.